Okay, so this video is going to be on chromatography. Okay, so chromatography is a really useful technique for separating molecules in a mixture. Okay, so what you need to know is a technique for separating different things. So it's used a lot in society, and it's used for identifying different things, okay? So it's used for identifying different compounds that exist within different mixtures or different substances, okay? So it's used for identifying additives in food, comparing fibres found at a crime scene, and identifying drugs and alcohol. Okay, so there are three main types of chromatography, which all work in the same way. Okay, so you've got paper chromatography, which is the one you will have seen in school. We have thin liquid chromatography, which is TLC, and we have column chromatography. Okay, so these all work in the same way, they're just used for different states of matter. So, your SQA definition of chromatography is you need to know that chromatography separates substances by making use of their different polarities or molecular size. So depending on how polar a molecule is, depends on where this will be separated. Okay, or also depends on its molecular size. Okay, so thinking of chromatography now. So our chromatography looks like this. So you've got a little beaker and it's got some solvent in the bottom. A lot of the time this solvent is a polar solvent, okay? And you have your chromatography paper here, okay? So your solvent is called the mobile phase and your chromatography paper is called the stationary phase, okay? So what happens is you add a sample that you're testing along here, okay? Much like this one here. Okay, so you draw a line and you add a dot onto the sample. Okay, once the sample has been spotted onto the paper, it's then partially submerged in your solvent. Okay, it can't be fully submerged because then this is going to drown your sample, that's what we say. Okay, so it can't be fully submerged, it has to be only partially submerged. Okay, so it's important that only the bottom is in contact here. So the bottom of your paper here, okay? Your chromatography paper is a highly absorbent paper, which means it only needs a little bit in order to absorb your solvent. So, after the paper's been added to the solvent, as I've said, it's a highly absorbent paper. Your solvent will start to travel up your paper. It will be absorbed up the way. Okay, so when it's travelling up the way, the solvent will come into contact with your sample as it passes the line that you've dotted it on here. Okay, and this is where it's going to start to separate the different components of your sample. Okay, so as I've said, your solvent travelling up, so here your blue liquid, when that travels up, this is called your mobile phase. This is because this is the phase that is moving, okay? So it's moving up your chromatography paper. And your chromatography paper here is known as your stationary phase. It's not moving, it's staying still, okay? So here, the sample is being separated by its components, by its polarity, sorry. So it's being separated into its components by its polarity. So as I've said, your solvent is usually a polar liquid. So as it travels up, it's going to dot, or as we say, drop off some components. Okay, so the further up the component travels, it means the more polar the component is. Okay, so we've got our polar solvent and it's travelling up, stopping up here at this line, which means this one up the top is really polar, okay? It's going to have a lot of differences in electron negativity. It's going to have a lot of oxygen groups, okay? So this, it travels up further because the solvent is polar, Okay, so the opposite attractions between the molecules of the solvent and the molecules of the component here are attracted to each other through their intermolecular forces. Okay, remember the difference in electron negativity causes one side of a molecule to be partially negative, one side to be partially positive. So this is how we can get these attractions. So all you need to know is the higher up the dot's going to be, the more polar the component is. Okay. It could also be used to test the purity of a substance. Right, so here we've got a chromatography paper showing a pure substance, so it only has one dot. Okay, for example, this could be used for seeing the purity of a tablet. Okay, so for example, let's say morphine. Okay, we could see that this only has morphine in it, whereas you could have an impure sample and you have different components in it. So yes, you have the morphine that you wanted, but it's also made up of different components. Okay, so pure substances should only have one dot. Okay, so basically that should be the only thing that's present if it's a pure substance. If it's impure, you're going to have more components, you're going to have more impurities here, which means you're going to have more dots, including the dot that you want. Okay, so when we're talking about the distance travelled, how far the dot goes up a piece of chromatography paper, okay, so the distance the components travel up the chromatography paper is called its retention time. Okay, so it's got, the further it travels up, for example here, it's got a high retention time. Okay, so this dot here is going to have a higher retention time than this dot here, because this one's travelled up further and then it's been dropped off here, whereas this one's been dropped off further down. Okay, so the retention time can be calculated and, the retention time can be read, and the components can be compared by calculating their RF value. Okay, so their RF value is the distance travelled by the substance divided by the distance travelled by the solvent. So here you would just get a ruler and you would measure, for example, let's do this one up here. You would measure the middle of that dot to where it started, so that would be this distance here. And then you're going to divide it by the total distance travelled by the substance. So that's going to be here. This is called your solvent front. Okay, so you're going to divide it by this distance. You're going to divide this distance by this distance. Okay, don't worry about this or remembering this. Don't worry about remembering this equation, because you're always given it if you're required to use it. Okay, so you'll always be given it, you'll always be told how to use it if you're ever asked to use it. Okay.